Okay, so the second question 3.2. So I can read here, it is given what would be the interaction between two copper spheres each of mass 1 gram, okay, separated by a distance of 1 meter if total electronic charge in them differed differed from the total charge of the nuclei by 1%. Okay, so just read this question very carefully. Here here what we have given is, we have total means each mass of each sphere is we are having 1 gram. These are made up of copper. So what you have to do here, in that 1 gram of copper, how many number of electrons are there, that you have to calculate. So how you can find is, you see, for copper we have atomic mass is 63.5. Here I have written total mass I am having is 1 gram. So number of moles I have calculated 1 by 63.5 number of moles multiplied by Avogadro's number, that will give me that number of molecules are there. Okay, so in one molecule, if you see, in one atom of that copper, if you see how many electrons are there or how many protons are there, it simply you can multiply its atomic number. Okay, so this value, that is 1 by 63.5 into 6.022, that will give you number of atoms of copper are there in 1 gram. You multiply this with 29, so this whole value you'll get that how many number of atoms, how many number of protons or electrons are there. You multiply that with the charge of one proton, or that is 1 point plus 1.6 plus 1.6 into 10 to the power minus 19 coulomb, you can multiply. So once you multiply this, so you'll get the value of total charge, out of which you have to take 1%. So when you consider 1%, then your net charge is going to be 440 coulomb. Okay, now you are going to find out that force. Here you see that here you are having two spheres like this. Each sphere is having 440 coulomb, 440 coulomb of charge. Each sphere they are having this much charge, 440, 440 coulomb. So now if you find out using that formula, electrostatic force kq square by r square, substituting this value, distance is given 1 meter apart, so you'll get 1.74 into 10 to the power 15 Newton. Okay, so here you can imagine that how strong means the electrostatic force magnitude is such a large quantity. It is such a large value. Even if we are considering that 1% of that charge present in 1 gram, then also you see such a large force it is coming. Okay, so this shows that how strong is electrostatic force. Okay, so next question we'll discuss.